So we are doing redox reactions chapter, right?
Yes, ma'am.
I cannot see your video. There's some I think camera problem. It's blank. Okay, no worries. So today we are going to do the redox reaction, that is redox without oxygen. Okay. So redox without oxygen means any reaction in which electron transfer takes place is a redox reaction. Okay. We have studied oil rig. Remember this thing, oil rig?
Ma'am, please repeat.
Pardon?
Please repeat what you just said.
I'm saying you remember this word, oil rig?
Yes.
It means oxidation is loss of electron and reduction is gain of electron. So any reaction in which electron transfer takes place, it is a redox reaction. So the redox reaction does not have to include oxygen. So my means to say is that redox reaction is also possible without oxygen. Okay, you remember what is oxidation? Oxidation, we have studied that it is the addition of oxygen or removal of hydrogen. And reduction, for that we have studied that it is the addition of hydrogen and removal of oxygen. Okay, the first definition. But then we have advanced studies that oxidation is loss of electron and reduction is gain of electron, right? So the redox reaction can be possible without oxygen also. For example, this is the reaction between sodium and chlorine. The chemical symbol for sodium is? The chemical symbol for sodium is?
Sorry, the chemical what?
The chemical symbol for sodium is?
N.
Na, right? And for chlorine?
Cl.
Yes, Cl. So if I write down the reaction between sodium and chlorine, I get sodium chloride. So we have to check, is this reaction a redox reaction? So let us see that the sodium atom give electron to the chlorine atom, forming ions as shown here. So sodium atom, it is losing electron. Basically, what is the electronic configuration of sodium? Can you tell me? Its atomic number is 11. So its configuration would be?
2,8. Wait. 2,8,1.
Yes. That means sodium can lose this one electron to achieve stability. But since there are two sodium atoms, that's why it loses 2 electrons. So oxidation is what? Loss of electrons. Sodium is losing electrons. And reduction is chlorine. The atomic number is 17. And what is the electronic configuration?
2,8,7.
That means chlorine is gaining this one electron. So basically, if sodium, two sodium are losing 2 electrons, so sodium, 2 chlorine atom, it will gain 2 electron to form 2 Cl minus. So reduction is gain of electron. So you can see here that electrons, if they are written on the right hand side of the reaction, that means it is oxidation. And if electrons are written on the left hand side of the reaction, then it is reduction. Okay, so this reaction is a redox reaction, right? Because loss of electrons is also taking place and gain of electrons is also taking place, and there is no use of oxygen. That means this is a redox reaction without oxygen. Okay.
Yes.
Okay. So let us see the second reaction example. That when chlorine gas, it is bubbled through a colorless solution of potassium bromide. KBr is potassium bromide. It is colorless. Then what happens? A reaction occurs. Okay, we have KCl and bromine. So this colorless solution, it will get converted into orange color bromine due to this reaction. Okay, so we can say that bromine has been displaced. So how to know this also? So chlorine, it is it is gaining 2 electrons and it's converted into 2Cl minus, similar to this reaction. So this is your reduction because electrons are coming on the left hand side. So if electrons are on the left hand side of the reaction, then it is reduction. If electrons are returned on the right hand side of the reaction, then it is oxidation. Now bromide ion. Bromide ion, it is losing 2 electrons and convert into bromine gas. Okay, so we can say that chlorine is reduction, chlorine is undergoing reduction, and bromine is undergoing oxidation. Is it clear?
Yes.
Write it down.
Done.
Okay. So this is a virtual, diagram that it is showing us that sodium, whose electronic configuration would be 2, 8, 1. When it loses 1 electron, so it becomes Na positive, so it becomes 2, 8 only. Similarly, chloride ion, it is 2, 8, 7. But when it gains 1 electron, it becomes 2, 8, 8. Okay. So this electron, this one circular electron, it is sodium atom has lost this electron to the chlorine atom. Now, we have studied that how to write down the half equations. Half equations are what we have studied in the previous class also, where electrons are involved. That is your half equation. You write a separate equation for oxidation. You write a separate equation for reduction, in which you show that how many electrons are lost and how many electrons are gained. But how to write down the ionic equation? So when you add both the balanced half equation, it gives you the ionic equation. What is ionic equation? An ionic equation shows the ions that take part in the reaction. So in ionic equation, electrons are not involved because we cancel all the electrons. How? Let us see. For the reaction between chlorine and potassium bromide, this is the half equation for what? Oxidation or reduction? Tell me. First one is the half equation for?
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Sorry, I was saying oxidation.
Pardon?
Oxidation.
I told you that if electrons are on the left hand side, it is reduction. Have you not copied this?
I have, ma'am.
So when electrons are the left hand side, so is it oxidation or reduction?
Reduction.
Yes. First reaction is reduction reaction and the second reaction is oxidation reaction. So you have to add both the equations. Cl2 plus 2 electron plus 2 Br minus, it gives me 2 Cl minus plus Br2 plus 2 electrons. Now you can see that 2 electrons and 2 electrons, they can cancel out each other because they are on the opposite sides of the reaction. So our ionic equation would be this. Cl2 plus 2 Br minus gives you 2 Cl minus plus bromine. So this is your ionic equation, which shows only the ions which take part in the reaction. Okay, no electrons are involved in this reaction. Is it okay?
Mm-hmm.
Write it down.
Done.
So what we have just studied, that oxidation is gain of oxygen or loss of electron. So we have to remember all the two definitions. It is gain of oxygen and loss of electrons. Reduction is loss of oxygen or gain of electrons. What is a redox reaction? Oxidation and reduction always take place together in a reaction, and that reaction is known as redox reaction. RED means reduction is also happening in the reaction, and OX means oxidation is also happening in the similar reaction. So we have studied many examples of a reaction in which both oxidation and reduction are taking place simultaneously. You want to write this?
Yes, ma'am.
Okay. Done?
Done. Yes, ma'am.
This is your homework question. Please take a screenshot of it. There are 3 homework questions. First question is you have to give a full definition for oxidation and reduction. Second question, what does a half equation show? Already explained. Third question is a reaction between potassium and chlorine to form potassium chloride. You have to tell me it is a redox reaction, why, and if you can write the balanced if half equations for it. That means electrons are involved in the reaction, in the oxidation reaction and in the reduction reaction. So take a screenshot of this question.
I've taken one.
Taken the screenshot?
Yes, ma'am, I did.
Okay. So next we are going to discuss about the oxidation state. What does oxidation state mean? Okay, so you can identify any reaction, like if the reaction is gaining oxygen, so you can say that it is oxidation. If a reaction is losing oxygen, you can say that it is reduction. If there is a loss of electron, it is oxidation. If there is a gain of electron, it is reduction. Third method by which you can identify the oxidation and reduction is by oxidation state. What does oxidation state mean? Basically, the oxidation state, it tells us how many electrons each atom of an element has gained, lost, or shared in forming a compound. What is an oxidation state? It tells us that how many electrons each atom have gained, lost, or shared in forming a compound. So there are some rules that relates that how to write down the oxidation state of certain element. So I'm going to tell you all that rules which you have to remember. First of all, write down the definition for oxidation state. So these are certain rules for writing the oxidation state. So very carefully listen all these rules. First rule says that each atom in a formula has an oxidation state. That if you are writing any compound, for example, I am writing sodium chloride. Okay, in this we have 2 atoms, one is sodium and one is chlorine. So sodium is also having an oxidation state and chlorine is also having an oxidation state. That means each atom in a formula has an oxidation state. It can be 0 also. Second formula says that oxidation state is given in a Roman numeral. You know what is a Roman numeral?
Yes, ma'am.
Okay. So if your number is 0, then Roman numeral is 0. If number is 3, it is like this. Okay. So if you want to write down the oxidation number, you always write it in Roman numeral. Third rule says that where an element is not combined with other elements, its atoms are in its oxidation state 0. Okay, that means if your element, for example, I am talking about Na only, sodium only, it is not combined with any other element, it is alone, so its oxidation number is 0. Okay, for example, let us take an example of silicon. It is not combined with any other element, so its oxidation state is 0. So it is very simple that when an element is not combined with other elements, so its oxidation number is 0. For example, H2 also. Okay, so in H2, hydrogen is connected with hydrogen only. Okay, not other elements. That's why its oxidation number is also 0. Fourth point says that many elements have the same oxidation state in most or all their compounds. Okay, for example, oxygen. So in oxygen, the oxidation state is -2 because when we write down the electronic configuration of oxygen, it will be 2,6. That means 2 electrons oxygen need. Okay, that means it is -2 because oxidation state is number of electrons gained, lost, or shared, right? So oxidation state of oxygen is -2 in most of the compounds. Okay, I'll tell you here. Hydrogen, it is +1 in most compounds. Okay, just a minute. Yes. It is sodium, it's +1. Calcium and the other group 2 metals is +2. Aluminium is +3. Chlorine is -1. Oxygen is -2. Okay, so these many elements have the usual oxidation states. Okay, so please Write down this slide. Rules for oxidation states. Once done, please let me know.
Okay. Finished.
Then now draw this table. That hydrogen, it basically shows the +1 in most of its compounds. Sodium in group 1 metal shows +1. Calcium in group 2 metal shows +2 oxidation state. Aluminium +3. Chlorine in group 7 non-metals show -1. Oxygen shows -2. But in peroxide, it shows -1. So this is the exception. So you have to learn this table, okay? Because when we calculate the oxidation state in the next class, then you should answer all these questions. So please draw this table.